There's a really neat thing that we can do with cosmology, which is actually measure how much neutrino particles weigh. So neutrinos are the tiniest particle, the least massive particle we know of. And actually, until somewhat recently, people thought they didn't have any mass at all. And now that we know that they do have mass, and again, they are actually a kind of dark matter. They're the sort of dark matter that we do know about, in the sense that they don't interact with us. But they do very, very weakly. They do very, very weakly interact. So cosmologically, they sort of behave like dark matter. And right now, there are billions of them flowing through, our hands or bodies at the moment. But they're quite mysterious particles. We don't fully understand why they have mass, really much about them. But there are enormous numbers of them in the universe. What's really cool is that even though you can try and measure their mass with laboratory experiments here on Earth, we can also try and measure their mass using their influence on how cosmic structures have formed. They're such tiny particles that when the universe was much hotter, they would have been like just traveling basically at the speed of light. That it's only their tiny mass that stops them from going completely at the speed of light. But when the universe was much hotter earlier on, they would have just been like traveling just really fast. The more kind of massive they are, the more of the dark matter they do make up. That's the big question we have. How much of the dark matter is these neutrinos? And they actually would have changed how big cosmic structures look. They kind of smooth out the features of giant cosmic structures. So what we can do is try and weigh them by looking at their effects basically on large cosmic structures. And so we're trying to do that using the CMB now actually as a backlight. We actually measure how much it's been kind of gravitationally distorted by all the stuff in between. We're looking at how much the light rays that travel to us have actually been gravitationally bent by matter on the way. And so we're using that as a way to try and detect how much these neutrinos weigh. I love the fact that you can use the entire universe kind of as a laboratory to sort of measure something, a fundamental physics thing like that.